The median is a fundamental concept in statistics. It is one of the key measures of central tendency, alongside the mean and mode. It represents the middle value in a sorted set of data. When the data is arranged in ascending or descending order, the median is the value that separates the higher half from the lower half. Imagine a group of people lined up by height from shortest to tallest. In this lineup, the median height would be the height of the person standing exactly in the middle. The median height would be the height of the person standing exactly in the middle. This means that half of the people are shorter and half are taller than this person. The median is a positional average. Unlike the mean, which is affected by every value in the dataset, the median is only concerned with the position of values. Its value depends on its position within the dataset, not the specific values themselves. This makes it a robust measure of central tendency. This characteristic makes the median particularly useful when dealing with data that is not evenly distributed or contains extreme values. It provides a better central value when the dataset has outliers or is skewed, ensuring a more accurate representation of the dataset's center. Calculating the median is straightforward, especially with a small, ordered dataset. Let's consider the following ages of students in a study group: 18, 19, 19, 20, 21, 22, 23. The median age is 20, as it sits in the middle of the ordered list. When dealing with an even number of data points, the median is the average of the two centermost values. For example, in the ages 19, 20, 21, and 22, the median is the average of 20 and 21, which is 20.5. The median shines when dealing with skewed data, which is data that is not symmetrically distributed. Skewed data can often be found in various real-world scenarios, such as income distributions, real estate prices, and even test scores. Skewness occurs when extreme values, or outliers, pull the mean away from the center of the data. These outliers can significantly affect the overall analysis, leading to potential misinterpretations. In such cases, the mean can be misleading as a measure of central tendency. For instance, if we only rely on the mean, we might overlook the true nature of the data distribution. Consider a data set representing the incomes of individuals in a small town. This town might have a few extremely wealthy residents alongside many average earners. A few extremely wealthy residents could significantly inflate the mean income, making it appear higher than what most residents actually earn. This inflated mean does not accurately reflect the economic reality for the majority of the town's residents. However, the median income would remain relatively stable, providing a more accurate representation of the typical income level in the town. The median is less affected by outliers and thus offers a clearer picture of the central tendency in skewed data sets. By focusing on the median, we can better understand the true economic conditions and make more informed decisions based on the data. Section 4. Advantages of the median. In this section, we will explore why the median is such a valuable statistical measure and how it can be applied in various scenarios. The median offers several advantages as a statistical measure. It is a central value that divides a data set into two equal halves, making it a reliable indicator of central tendency. First, it is simple to understand and calculate, even without a strong mathematical background. You don't need complex formulas or advanced software to find the median, which makes it accessible to everyone. Second, it is resistant to outliers. Outliers are extreme values that can skew the results of other measures like the mean. Unlike the mean, which is sensitive to extreme values, the median remains relatively stable in the presence of outliers. This makes it a more robust measure when dealing with data that may have anomalies. Third, the median can be used for ordinal data, which is data that can be ranked but not measured precisely, such as levels of satisfaction or agreement. This is particularly useful in surveys and questionnaires where responses are often ranked. This flexibility makes the median a versatile tool in statistical analysis. Whether you are dealing with small data sets or large, complex ones, the median provides a straightforward and reliable measure of central tendency that can be applied in various fields from education to business analytics. Section 5. Limitations of the median. While the median is a powerful tool, it does have limitations. One limitation is that the median does not take into account the actual values of the data points. It only considers their position in the ordered set. This characteristic can be a disadvantage when the magnitude of the values is important. Another limitation is that the median can be less efficient than the mean when dealing with large data sets that are normally distributed. In such cases, the mean is a more precise measure of central tendency.